Greetings, math students. It's Mrs. Marcellus, and I'm here with today's special guest, Einstein. In today's lesson, we are going to learn to multiply decimals by whole numbers. Today's learning objective is students will calculate the product of a whole number and a decimal number by estimating and applying standard algorithms. As we learned in the previous lesson, a standard algorithm is just a standard process, so today we'll be using standard multiplication. Shall we proceed to the vocabulary and some examples, Einstein? All right then, let's move on. Today's vocabulary word is product. Product is the result of multiplication. When multiplying decimals, there are a few things to remember. First, you do not have to line up the decimal points like you do with addition and subtraction. Second, to place the decimal point in the product, or the answer, you count the number of digits to the right of the decimal in the problem. The product must have the same number of digits to the right of its decimal. And third, you might have to annex some zeros in the product. Let's go to our first problem. Find the product of 3 and 78/100ths. One of the things you'll have to decide is which number you want to put on top and which number you want to put on the bottom. In multiplication, it really doesn't matter, but sometimes one way is faster or more efficient than the other, and so you're always going to want to look for the quickest route to the answer. So let's go ahead and do the first problem. 0 and 78/100ths times 3. And again, I'm using graph paper here just so we can keep everything nice and neat and lined up. And you can see here that I did not worry about lining up the decimals. In fact, you basically ignore the decimal until you get to the answer and need to place it. So we go ahead and do our multiplication. I start out with 3 times 8 is 24. I write down the 4 and I carry the 2. Then 7 times 3 is 21, plus 2 more is 23. And then I go ahead and carry the 2. 3 times 0 is 0, plus 2 gives me 2. One mistake I often see students make is they'll say 3 times 2 is 6. You want to make sure when there's a 0 there that you multiply times the 0 first, then add anything you carried. Now, to place the decimal point, I will count how many digits come to the right of the decimal in the problem altogether. And the 7 and the 8 are both to the right of the decimal, so that means there are 2 digits to the right of the decimal in the problem. So in the product, I will also need 2 digits to the right of the decimal, 2 and 34/100ths. Now, if you'd set the problem up the other way, you could have put the 3 on top times 0 and 78/100ths. 8 times 3 is 24. And then we'd have to start a new row. And since I've already used this place value, I put a 0 to start the second row, and then I can go ahead and multiply 7 times 3 to get 21. Then I will add up the rows, and I get 234, which we know is not the correct answer because I still need to put the decimal point in there. We count the number of digits to the right of the decimal in the problem, and we see that there are 2, and we mark those off and put the decimal point there, 2 and 34/100ths. So either way you do the multiplication problem, you're still going to get the same answer, but the first example was more efficient because you went directly to the answer, where in the second example you had 2 rows of multiplication. You had to make sure that you annexed that 0 on there. Well, you didn't really annex it, but you added it as a placeholder, and then you have to add them up. And then we kind of ask ourselves, does this answer make sense? I'm taking 3 whole units times something that's less than 1. That would mean that my answer would be a little bit less than 3. And we got 2 and 34/100ths, so that makes sense. Going on to our next problem, 6 times 13,000ths. So we're going to get a very tiny answer here. We're taking a whole number times something very, very small. In this problem, let's put the 13,000ths on top. because if I put that on the bottom, that would mean 2 rows of multiplication. But if I multiply by the single digit 6, I only have 1 row of multiplication. I go ahead and multiply. 6 times 3 is 18, and I'll carry the 1. 6 times 1 is 6, plus that 1 that I carried is 7. I don't carry anything, so now I have 6 times 0 is 0, and 6 times 0 is 0. And I count the number of digits to the right of the decimal point, 1, 2, 3. And in my answer, I would count 1, 2, 3, and my decimal point goes there. And my answer is 78 thousandths. And here we have 45 thousandths times 23. In this problem, either way that you set it up, it's going to result in about the same amount of work because each one of these has 2 non-zero digits in it. So let's take a look at doing the problem both ways. First, you could start with 45 thousandths times 23, the way the problem is written. And then we'll go ahead and do our multiplication. 3 times 5 is 15, and we'll carry the 1. 4 times 3 is 12, plus that 1 is 13, so I'll carry the 1. 3 times 0 is 0, plus 1 more is 1, and 3 times 0 is 0. Then we want to go to our next row. I'll do this row in red. First of all, we've already multiplied by the 1 spot. To start our second row, we need a 0 just to mark off that place value. So 2 times 5 is 10, and I'll carry the 1. 2 times 4 is 8, plus that 1 I carried is 9. 2 times 0 is 0, and 2 times 0 is 0. Then I need to add the two pieces together. I end up with 5, 3, 10, I'll carry the 1, 1, and a 0. Then in order to put the decimal point in, I count how many digits come to the right of the decimal in the problem, and that would be 3. In my answer, I have 3 digits to the right of the decimal as well. And I end up with 1 and 35 thousandths. Now if I flip the problem over, I will still get the same answer. 3 times 5 is 15, I'll carry the 1. 2 times 5 plus 1 gives me 11. Now switching colors, we'll start that second row. Again, we'll have to start the second row with a 0, and then we'll go ahead and multiply. So now I'm multiplying. 4 times 3 is 12. I'll carry the 1. 4 times 2 is 8, plus that 1 is 9. Now, that concludes the second row. After that, I have zeros left. You could write in the 2 zeros and then multiply times 2 and multiply times 3. So you've got a row of zeros, and then fill out another one and more zeros, but that's really not necessary because really it just kind of adds a bunch of gunk to the problem, and we don't want to have all that stuff there. When you're adding 0, you still have the same number you start with. So if you have to multiply by 0, you don't have to write all that down. So we'll go ahead and add up our numbers, and we end up with the same answer. I count over the number of digits, 1, 2, 3, 3 to the right of the decimal in the problem, 1, 2, 3 to the right of the decimal in the answer. Either way, you get the same answer, and it's not necessary to write down extra rows of zeros in the problem when it's not going to change the results. Our final problem of this lesson is a word problem. Wanda is making 8 batches of trail mix. Yum! The recipe calls for 1.2 cups of raisins for each batch. She already has 5.7 cups of raisins. How many more cups of raisins does she need? This is going to be a multi-step problem. The first thing we need to know is what is the total amount of raisins that Wanda needs? And in order to do that, we'll need to multiply. Wanda is making 8 batches, and there are 1.2 cups in each batch. So we know that would be 1.2 plus 1.2 plus 1.2 and so on. So repeated addition is multiplication. We'll go ahead and multiply 1.2 times 8, and we learned that Wanda needs 9 and 6/10 cups of raisins altogether. She already has 5.7 cups of raisins. How many more does she need? This is a big clue that we're finding the difference between the amount she needs and the amount she already has. She has 5.7 cups plus some unknown number to equal 9.6 cups total. In order to find that difference, we'll need to subtract. And when we subtract, you have to line up the decimals. We'll start with the 9.6 cups of raisins Wanda needs to make the 8 batches. Then we'll subtract the 5.7 cups of raisins she already has. This will tell us how many more cups of raisins Wanda needs. We cannot subtract 6 minus 7, so we'll have to borrow. So we'll take 1 away from the 9 and make that an 8, and add 10 onto the 6 and make it 16. 16 minus 7 is 9. 8 minus 5 is 3. And that tells us that Wanda needs 3.9 cups of raisins to make her yummy trail mix. I don't know about you, Einswine, but all this talk about trail mix is making me awfully hungry. What do you think? Should we go find a snack? Well, that does conclude our lesson on multiplying a whole number times a decimal number, so we're going to wave bye for now.